Hey everyone, today we're going to be doing a new exponent rule called the power to a power rule, sometimes also known as just the power rule. Alright, and I want you to start off with this example. How can we begin to simplify the following expressions? I want you in your notebook just to kind of write down a couple things that you think we could do to simplify the following expression using what we already know. When you're ready, you can unpause the video and we can continue. Alright, so as you know, it's 5 to the third to the fifth power. So this entire 5 to the third is being raised to the fifth power. So what we could do is we could use our knowledge of expanded form, right? 5 to the third is our base here. This is the base in this case, and the 5 is the exponent. So we could write it as 5 to the third times 5 to the third times 5 to the third times 5 to the third, right? Because 5 to the third is being raised to the fifth power. So it's being multiplied by itself 5 times, 1, 2, 3, 4, 5. So if that's the case, we can use the product rule and add all those 3's and we get 5 to the 15th. Another way we could kind of think of this is that 5 to the third to the fifth is that 5 to the third can be written as 5 times 5 times 5. And that is all being raised to the fifth. So we could write it as 5 times 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 5. And that will give us 5 to the 15th because we're multiplying 5 15 times. Either one of these ways is a fine way to simplify this. So what we're going to do next is I want you to do this. I want you to put this into practice with these 4 questions. So I want you to do your best. Pause the video. In your notebook, I want you to do the following. So I want you to write these in expanded form, just like we did the warm-up, okay? When you're ready, unpause the video and we will go over it. All right, so here, x to the third power, so it's x to the third times x to the third times x to the third, which gives us x to the 9th power. Right. Over here we have 4 squared to the third power, so it's 4 squared times 4 squared times 4 squared, which gives us 4 to the 6th power. And lastly, here we have 2x squared. That whole thing is being raised to the third. So it's 2x squared times 2x squared times 2x squared. And here it's going to be 8x to the 6th power, right? Because here we have 2 times 2 times 2, which is 8, and that's the 6th. Some of you may have written 2 to the third, x to the 6th, and that's correct. But remember that 2 to the third is also 8, so both of those answers are right. And here we have negative 3y cubed raised to the third power, so it's negative 3y cubed times negative 3y cubed times negative 3y cubed. And that will give us negative 3 to the third, y to the 9th. And negative 3 cubed is negative 27y to the 9th. So there you got to make sure that that negative drags in. So here, I'm sure you can kind of think of it. What's our general rule? If we have a power raised to a power, an exponent raised to an exponent, what could we do to those exponents to simplify this quicker? Multiply, right. So when we have a power or an exponent raised to another power or exponent, we can multiply the exponents. Let's take a couple look at some examples. And we'll kind of use the ones that we kind of just did. So x squared to the third, right? We have a power raised to a power. So the one power is the square and the other one is the cubed. So we can write it as x to the 2 times 3, which is just x to the 6th power. We don't have to write it all in expanded form. Same thing with that 4 squared to the third. It's just a number, so we can write it as 4 to the 2 times 3, which is 4 to the 6th power. And here we got to the 3rd power, so let's try something different. So what about negative, no, we'll just keep it 2 to the 4th to the 5th, negative 5th power, right? So now you have the 4 raised to a negative 5, and that'll give us 2 to the negative 20th, and as you know, we can rewrite this with a positive. Move it and then lose it, you got 2 to the 20th power. It gets a little bit more complicated when you have more than one thing being raised. So let's try like x to the 2nd, y to the 3rd, all raised to the 4th power. It's kind of like the distributive property here. You have a 2, a 3 exponent raised to a 4th. Both of them are going to be multiplied. So x to the 2 times 4. So I'm going to rewrite this kind of like we do with the distributive property. So it's kind of like x squared is also raised to the 4th times y cubed is also raised to the 4th. So then you're left with x to the 8th because 2 times 4 is 8, and y to the 12th because 3 times 4 is 12. So that outside exponent multiplies to both of them, right? And this is only when it's a power to a power. We can't mix these up. Option 5. So let's do negative 2 x to the 3rd raised to the 2nd power. So again, like the number 4, that negative 2 actually has a little exponent. It has a little imaginary 1. So that outside 2 is raised to both the 1 and the 3. So it's actually negative 2 raised to the 2nd power and x to the 3rd raised to the 2nd power. And negative 2 squared is 4 because negative 2 times negative 2 is 4. And x to the 3rd squared is x to the 6th because 3 times 2 is 6. If we had something like negative 3x squared y all to the 3rd power, again, that outside 3 is being raised to an imaginary 1 over the 3, the 2 over the x, and the imaginary 1 on the y. So the best way is kind of break it up like the distributive property. And we have here negative 27, x to the 6th, y to the 3rd. Okay. It seems relatively simple, but it can get confusing when you have multiple things in the parentheses at once. Okay? Your goal for today is to complete this problem set, and that is it. Have a wonderful